Hey there, this is Chidanand from Kratz Infotech NG. Welcome to this introductory session on Git with GitHub. Git is a source code version control tool, very popular in recent times. There are various flavors of the Git server. This session, I'll just try to touch upon a few aspects of Git and use it with the Git server called GitHub. So what do we plan to cover in this session? First of all, we'll try to understand what is a source code version control system. Why does one need it? And then maybe look back at what different types of version control systems have existed and what is majorly the difference between something called as centralized or client server version control systems and then the new breed of version control tools which fall under the category of distributed version control systems. Now, Git is a distributed version control system, and it is very important to know, if not all the differences, at least some of the major differences between how centralized version control tools work versus how distributed version control systems work. And in the end, I will try to wrap it up by creating a brand new Git repository using a Git client, then link it to a GitHub server and push it or publish it using HTTPS authentication. First things first, let's try to understand what is source code version control system, why were these even developed, what is the need for it, and what problem do they try to solve. Source code version control tools have been there existing since the 70s or the 80s. Have been there for a long time now. It's gone a lot of changes in the way they've been designed and developed. But then the whole idea is assuming that we have a bunch of developers, a development team, where for the sake of argument, we have four developers. All of them are going to work on a particular project. Maybe it's a development project. They're going to write some sort of source code in any programming language, be it Java, .NET, C, C Sharp, Fortran, COBOL, any programming language. All the code may possibly exist in one folder. Now, how is that one folder going to be shared between all these four developers? So that developer one knows what the developer two is doing, because in all possibilities, they're going to work on the same set of files. How do you ensure that when one developer is working on a particular file, the other developer either gets to see what is happening or is restricted from seeing what this developer is doing until this guy has committed and checked in or pushed that particular code into a centralized folder? In order to control all these actions, source code version code tools or source code version control systems, source code version control systems were developed. Now, the oldest ones were all based upon something called file system. There was a file system where a particular folder, and if you go back in history, they were usually the old ones were either mainframes or Linux boxes where everything was there on a big server. So, using the file system, somehow some sort of controls were put out by these tools, which ensured that they could all collaborate. Then came another breed of version control systems, which were known as either client server or yeah, basically they were called client server tools, or in some way people used to refer to this also as centralized version control systems, because there was a huge server which was serving all the all the source code out of one particular machine. Later, in recent times, in the 2000 or late mid 2000s, we had another bunch of systems which fall under the category of something called distributed version control systems. Distributed version control systems. Now, this is the background of source code version control systems. Before getting into Git, it's a little important to understand a little bit about the major difference between the so-called centralized or the client server one versus distributed one, because many of you if at all you're starting to use Git, you would notice a lot of difference in the way the workflow runs on Git as compared to the older or centralized one. In the centralized version control system, this is again going back in history where disk space was at premium. There is one huge server under the hood. There could be multiple servers supporting this, but for all practical purposes, it was one big server that had all the revisions, all the files, all the version control database, so-called database of all the versions, tags, revisions, and of course, not to mention the files also that is present on this particular server. All the version control activities used to happen with this particular server. Meaning, if anybody wants to work on any particular revision, the client will have to submit a request saying, you know what, I want to check out this revision. Or some of them were even based upon file. Files could be checked out for read purpose or a write purpose. Specific flavors or specific versions of the files can be checked out. And if somebody has checked out the file for a write purpose, it was the file used to be locked. The other person could not be able, I mean, would not be able to pull out this particular file for a writing purpose. Maybe it allowed him to look at it from a read perspective. Okay, the server down, pretty much most of the version control tasks are kind of stalled. You couldn't do anything because the server is down. That is the heavy dependency on the centralized or the so-called client server version control systems. Now, with the distributed ones, you would notice you would not find any difference between what is, I mean, you cannot make out what is a server and what is the client. So when I say client, it's nothing but the developer or the development machine on which a light tool would be installed. Now, if you see here, exact replica of what is there on the server is also there on each and every client that is connected to this distributed server. Now, when we say distributed server, doesn't mean that there's no server at all. There is one server definitely, but then the version control tasks can all be done locally. Complete distribution, or it is like a total way of decentralizing the version control tasks, meaning the developer one, if he kind of goes in here and maybe clones a repository is nothing but a folder with all the history. The complete replica of the repository is cloned out here. Now, of course, if you don't want all that, there are ways of kind of disabling it, getting only things that you need. But then when you work on it, that's exactly what happens in the default way. You get all the revisions and everything out here. Now you can commit here. You can do a lot of version control tasks in the client itself without really having to worry about the server. You can push and pull the changes in an asynchronous way. Complete different in terms of how this works versus how this works. Okay. Also, if you notice, um, developers can also push their changes between them without really going to the centralized repository. Now, this is completely controlled. If the server is down, everything is down. Even if you want to clone into some repository, get some code, you have to have a lot of permissions. Out here, completely decentralized. Complete decentralized. Of course, you can put all kinds of controls out here as well. But then the idea is you can commit, you can do version control tab without even a network connection. Later, when you want to push these changes, okay, you can push. And of course, before you want to push, you want to probably pull and check if there's any incoming changes, but then completely decentralized way of dealing with the server. That's the big difference between centralized versus distributed. A little bit of an overview about what is a Git client and what is a Git server. Very important to understand this because many people do not understand this aspect about Git and the Git server. Git client, you can read up on Git client. It's a beautiful tool that came out of this was the tool that was used by Linux developers when they were developing the Linux kernel. Can you imagine the kind of churn that this would have gone through? A beautiful open source, freely available tool, which is available on Windows, Linux and macOS, completely free of cost. Now, with the Git client, you can do a lot of stuff, but then when you want to really push it to a server, you would need a pretty expensive server. Of course, there are lots and lots of free servers available, but then you need a beautiful UI, you need some sort of a control mechanisms, you need some sort of an authentication, you need a kind of UI possibly to review the codes. And then these days, if you look at GitHub and GitLab, the complete CI/CD pipeline, everything is present on these Git servers. Now, discounting all that, the server can be any server of your choice. It could be GitHub, Bitbucket, GitLab, or Gitia, or if you're on the cloud, public cloud, AWS Code Commit, Azure Repos, any of these servers, it just doesn't matter. Git client can communicate with all these Git servers. So what do I plan to do in my demo is, assuming this is my laptop, I'm going to install Git client, and then I will run small configurations. Um, Small configuration just to set a username and email ID. And then, of course, let me take a look at this. And then later, I will create a repository here, right here on the client. I don't even have to need, I don't need a Git server at all. I can do a lot of my version control tasks using Git without even needing a Git server. So I will create a repository or initialize a repository, maybe put in some files here, do one or two commits. And later I will link it to a Git server of my choice. Now, in order to use a Git server, you will have to get an account on either the public server or any other server wherever you would want to push this repository. Now, once I do that, I will push this particular code that is already initialized and one or two code committed using, maybe I'll use HTTPS to publish this repository on to the Git server. I already have the Git client installed, but in case somebody is interested, you can just go to Git client, download the Git client. The Git client is available on Linux. Linux, it comes actually pre-installed on Windows and for Mac OS. Now, I already have that downloaded and done the installation as well. The default installations, nothing customized. If at all I open something called as a Git Bash, you would find a beautiful bash kind of a thing, because I told you, yeah, the Git came from the development activities of Linux. So this bash gives you a beautiful feel of working on a Linux machine. That's how Git Bash kind of works. So if at all you see this, this is the way where you can operate all your Git commands. Now, if you put this on the path as well, you can even run it with a command prompt or a batch file as well. But I prefer to do this because there's some nice color scheme out here, which looks pretty good. So I have the Git client installed with all the Git configurations. I've also done a bit of these two configuration that, you know, specifies what is the user who is using Git, and that at a global level, and then what is the email ID. Now, if at all I do a git config -- list, it will tell me all the configurations that is present. Okay, now you will notice user.name, Chidanand, Chidar, and user.email. Now all the others came from the default installation of Git, even including, I would like to point out to one of the important things, what is the default brand? Okay, all these configurations come in with all the default setup. All right, so I have that installed. I have the Git client installed, everything set up. Now all that I got to do is create a new Git repository. Now, in the distributed way, I told you, it's all completely decentralized. You don't even need a server. All right. So let me create a folder. Let me first check where am I. I'm right here. So let me create a folder, MK directory, maybe YouTube. Let me create everything in small case, YouTube hyphen git hyphen demo, cd YouTube hyphen git hyphen demo. Now this is a simple folder for all practical purposes. I told you, when you talk about a repository, the repository is nothing but a folder in which you can put the source code of any version control tool that you would want to. Now, out here, I'm going to quickly demonstrate using a simple text file kind of a thing, but then the same commands, everything remains the same for any other source code that you may choose. So this is the folder, an empty folder. There's absolutely nothing out here. Um, Let me just take a look at hidden items as well. Okay, that sounds good. So now either I can put some source code here, then try to initialize a repository, or I can initialize a repository by running a simple git command. So git init. Okay, now you see git the Git client created a repository out of nothing. And this is the master, which is nothing but the default branch as per our setup. And the Git terminology, these days it's all main, that is the branch, that's the default branch. But going back, the default ones is usually master. So now what Git did is, if you notice here, it will create a folder called .git. Now this is supposed to be an hidden folder. If at all you choose this, or rather uncheck this, you will not find any folder here. So this contains all the metadata about the repository that you're going to create. Okay, so let me choose that. So now, in a layman's term, in this folder, Git will start tracking everything that is going to happen in this particular folder. It's like the big boss camera being switched on in this particular folder. Now, if I create a bunch of files out here, let's assume that that is my use case. Let me just run notepad hello.txt. All right, I'll just create a file, just create a text file. This sounds good. Hello world, and I saved the file. Now, if at all I just say git status, it tells me that, hey, you know what, buddy, you got a new file. When you initialize the repository, there was nothing here. Now I see a new file. I don't know what is this file. I'm totally not tracking this. Do you want me to track it? Okay, how to get the file to be tracked by git add. So git add dot, or I mean dot is a kind of wild character, so that it adds everything to the whatever is there well within the subfolders. Everything gets added to something called as a git index, or Git will start tracking this. Git add dot. Now if you see the git status, see here, now it starts tracking this. Whatever was red started getting green. Looks good, meaning Git knows what changes have happened here. And but then you're not committed anything yet. Okay, so do you want to really go and commit something? So commit is something where you finish off a task. It could be a feature, it could be a defect fix, it could be a bulk of activity which you would want to be tracked inside your version control tool. Okay, you want to give a name, or you want to give a commit message. Now assuming that this is okay, this is all that I wanted to put in my git repository. If at all I say git commit, okay, first commit. All right, now I actually created a version of the source code that I checked in. Now if at all you just say git status, everything looks nice and clean. Git log, you see how many commits have happened. One commit has happened. And who committed it? Me. Now where did Git get these two information? From the git config command that was run. Now can you imagine doing all this without really even worrying about the particular server in the background? And that is the difference between distributed and centralized. Now what I'll do next is, let me go to my GitHub and create a repository with the same name, and then somehow link it together, link this client to my server, and then push this particular code. Now we'll notice that I did all the Git client part of it without even having a server on my mind. Now I would need a server. The server is required because I'm going to push my code here, and assuming my friend would want to work on this, he can be on some other machine. The server is a place from where everything gets collaborated. So now we would need a particular server. Distributed doesn't mean there's no server. It just means that the source code activities can also be done on the local machine without really involving the server at each and every single version control tasks. Now what I'm going to choose is a GitHub. You would need to have an access to GitHub. I have already an access to my GitHub repository. I have a username, password, and this is my GitHub handle. GitHub handle is nothing like your Twitter handle, a small identifier that identifies my public ID out here. So I'm going to link my Git client to this particular server. Now, there are a lot of tools. Again, depends upon the server that you're choosing and the IDEs. So many IDEs are there, like your Visual Studio Code. They have direct integration using auth tokens, which enable you to directly push the repository or synchronize the clients with the server. Now, if at all you're doing in a layman's way, if at all using Git client, you would have to go here and create an empty repository just to link up the client and the server. The client is not capable of pushing a repository that doesn't exist onto the server. So we'll go here to the Git server and create an empty repository with the same name. The repository that I created on my local was called this YouTube Git demo. So I'll have to create a repository with the same name out here. When I say repository, it's just an empty one. It is not going to have any code or anything of that sort because the source code has already been committed. It is available on my local. So I will create an empty repository with the same name and then link it together. Now, please note that I will use the HTTPS authentication. The Git client and server usually use either HTTPS, which is not so popular. SSH key is a lot more popular. And of course, if you're using some IDE, there are lots and lots of connected devices and stuff like that, where depending upon the IDE, there's a lot more close association between the client and the servers. Out here for this quick demo, what I will use is, I will use the HTTPS authentication, which wants a username and password. So let me go to my Git server and create a repository with the same name. All right, new repository. What is the name of my repository? My repository is under my ownership. If you have some teams and organizations and stuff like that, you can create in any one of them. But then keep it simple. This is the repository. What should be the name of my repository? The name of my repository should be exactly this. You can name it in any other way that you want to, but then it makes sense for the client and server to have the same names. Okay, you want the repository to be public or private? For me, public is okay. I've got nothing important out there. Do you want to initialize the repository? No. Our repository is already initialized with one commit already there. Okay, we don't want to initialize. Do you want to add anything else? Absolutely nothing. So just go ahead and create a repository. So now I have a repository, a plain repository or an empty repository with a URL. The most important thing is, what is the URL? All right. Now out here, it even tells me how to push an existing repository from the command line. So on my client, all I got to do is add a remote with a specific name called origin. And what should it point to? HTTPS URL. Now you can flip this URL between HTTPS and where is SSH. SSH. If you have the SSH keys, maybe I will do another tutorial on how to set up an SSH key and link it. But then for now, I will use HTTPS. Okay, so git remote add origin, this particular URL. I got to do this here. So right now, this is a kind of an empty or a repository on the client without any server being linked to it. So you add origin. Okay, now you can have multiple origins also in case you want to. You can, your URL right now is pointing to GitHub, but if your repository is on Bitbucket, if your repository is on GitLab, if your repository on Git or any other place, wherever you have access to, the setup is all going to be the same thing. Okay, all that you got to link is this remote add. Okay, you're going to add the remote. Let me just check if the remote is good. Okay, this remote is good. If it makes a mistake, you can go ahead and correct it. Absolutely no problem with that. Now we will like to push this repository. Okay, now this is to convert the branch to main. My branch is called master. I'm good with that. I don't want to, I don't want to rename my master branch. Some people find this little offensive, which is why in recent times it's always said that your default branch should be main, but I'm okay with master. So git push, I'm going to push, okay, -u. First time you're going to push the code, uplink, okay. What is that you would want to push it to origin? So which branch do you want to push it to master? Now, at this point in time, the authentication happens. Since I've used HTTPS URL, it's going to ask me for a username and password. My username and password is always cached, so it may not ask for my username password. But when the first time you're going to push this out, it is going to ask you for your username password. Now, assuming that you type in your username password correctly, you'll see here now the repository got pushed. Now, a remote tracking branch, a branch out here in the local, which tracks whatever is happening on the server, also gets created. Okay, now I don't want to go into that part of it, which may be a little confusing at times, but then visualize this way, that a branch that was a master here got pushed to the server as the same, with the same branch. So if at all I go here and refresh the screen, okay, now you see hello.txt with a commit, one commit. And if you see the commit, commit ID, DA something, that's exactly what our um, Git, okay, this is the commit ID with the commit message called first commit got pushed here. As simple as that. Now, all the remote add and everything has to be done only the first time. Now, after that, your client and server are all connected and hooked up. So in case you want to make one more commit, let's just maybe add another file, vi by.txt or something like this, goodbye or something of this sort. I type in, okay, git status, git add dot git commit -am second commit. Okay, and then I don't have to do any of those git remote add and everything. I know for a fact that nothing has come in, so I can directly go and do a git push. Automatically, the second commit also get pushed. See, first commit, if I refresh this, second commit. The second commit is, I mean, it's all based upon the timestamp, not first and second. So this commit, for this commit, this guy is the parent. So linking it, doing a lot of version control tasks right on the client without really worrying about the server. Of course, if somebody would have committed and pushed something else in between, the way you would operate is you'll have to first pull that particular code. Now that part of it, I will kind of hold this for another day. But for now, how to create a local Git repository, push it to the server is as simple as this. Thank you so much for stopping by and watching my tutorial. I hope you enjoyed it. If you have any questions regarding the tasks and the command that I ran, kindly leave me a message and I'll try to address it as soon as I can. Thank you so much.